Okay, I'm continuing to try new things. So let's just see how it goes. Can you all see the notes? Well, let me know. So today we're looking at section 6.1. We're going to see about solving a general right triangle, applications of right triangles, and finding bearings. So in general, from this point forward, an uppercase letter will represent an angle. A lowercase letter will represent the corresponding opposite side. So for instance, angle C is here in capital, little c is the angle opposite. Capital B is here representing this angle, little b is the side opposite, and the same with angle A and small a. To solve a triangle, you want to find every side and every angle for that particular triangle. So if you know one non-right angle, so let's say we have, let's say C is a right angle, which it isn't actually in that triangle, but let's assume that angle C is 90 degrees, or pi over 2. Then all I need to know is either angle A or angle B in order to know all of the angles of that triangle. Why is that? Well, what if we know that angle A is, let's say that it's 30 degrees. We also know that angles A plus B plus C is 180 degrees. Angle C was 90. So if we subtract 90 from both sides, we get that angles A plus B are 90 degrees. Well, we know that the measure of angle A is 30. So I can subtract 30 degrees from both sides. And I get that the measure of angle B is 60 degrees. If you know two of the sides of a right triangle, you can figure out the third because you know the Pythagorean theorem. You know that a squared plus b squared, the two legs, equals the square of the length of the hypotenuse. Also, if you know one angle and one side, you can use one of the trigonometric identities to find the remaining sides. So let's play with that. What if we know that the legs on a right triangle are 12 and 5, and the angle opposite, the leg of measure 12, oh, I see, I'm not reading well. Okay, so we want to find all of the information for that triangle if we know I cheated, I read the problem correctly. So now with the problem in front of us, we know we have a right triangle, the legs are 12 and 5 measure respectively. The angle theta is opposite the side of measure 12, and we want to find all the trigonometric functions with respect to theta. So we need the length of the other side. Let's call that C. And how can we find that? If we know that C is opposite the right angle. Exactly right. We're going to take 12 squared plus 5 squared. We know that that's C squared. So 144 plus 25 is C squared. We know that C is positive, so when I take the square root of both sides, I only need to consider the positive. That's why I don't need a plus or minus sign this time. So we know that the hypotenuse has measure 13. We want to write down the sine of theta, the cosine of theta, the tangent of theta, and now I'm gonna, well, let's do those first. With respect to the sides of a right triangle, sine of theta is opposite over hypotenuse. Well, opposite is 12, the hypotenuse is 13, so we get 12 over 13. The cosine of theta is adjacent over hypotenuse. The adjacent side, remember, only legs, not hypotenuses, only legs can be adjacent. So the adjacent side is 5, the hypotenuse is 13, there we go. The tangent of theta is opposite over adjacent. So that's 12 over 5. Every other trigonometric identity is the reciprocal of one of these. The reciprocal of sine is the cosecant. So all I have to do is find the reciprocal of sine. So the cosecant will be 13 over 12. The reciprocal of cosine is the secant. So the reciprocal of cosine, that's 13 over 5. That will be the value of the secant of theta. And finally, the reciprocal of the tangent is the cotangent, and that'll be 5 over 12. So we solved, we didn't find what theta was. So let's do that. Let's find theta, and I'm going to call the other angle alpha. How can I find theta if I know the sine of theta, the cosine of theta, etc.? What can I do to find theta? The easiest way is to use the tangent. If the tangent of theta is 12 over 5, then the inverse tangent of the tangent of theta is theta. The inverse tangent of 12 over 5, well, let's get our trusty calculator out. And let's see what we get. Let's put this in degree mode. Do you see the little radian here? I don't want that. Here we go. I want no radian means that it's in degree mode. So I'm going to enter 12 over 5, 12 divided by 5. And now second on my calculator gives me inverse tan. And I'm going to do one decimal place. So I get the angle theta is approximately 67.4 degrees. How can I find angle alpha if I know angle theta? Exactly right. 90 degrees minus theta. The two angles have to add up to 90 degrees. So if I subtract theta from both sides, I get alpha. And what is 90 degrees minus 67.4? Again, this is an approximation because the measure of angle of theta was an approximation. And let's do 90 minus 67.4, and we get 22.6. Let's see if I'm kind of on track with angle theta, with angle alpha. So from the point of view of angle alpha, I know that its sine should be 5/13. Let's see what 5/13 is, and let's see what the sine of 22.6 is. That should be the same. So 5 divided by 13 is 0.3846 approximately. And the sine of 22.6 degrees, okay, 22.6, I'm going to take the sine, and I get 0.3842, yay! So it's not exact, but that's okay because we're not exact in the fourth decimal place. Excellent. So you can see how these questions are going to proceed. Let's solve the right triangle with the following information. I'm going to let angle C be my right angle. And I'm going to do the others in alphabetical order so that angle B is 52 degrees. Angle A is the side opposite angle A. And it equals 11 units, whatever that is. Side B is the side opposite angle B. Side C is the hypotenuse, the side opposite angle C. How can we find another side of this triangle? Because if we have two sides of a right triangle, we can find a third. Well, what trigonometric identity for angle B will involve both side A and side C? What trigonometric identity for angle B will involve side A, which is, oh, it's adjacent, and side C, hypotenuse? Exactly right. We know that the cosine of B is equal to adjacent over hypotenuse. The adjacent side is 11, and the hypotenuse is the side we don't know. It looks like we don't know two things in this equation, but that's not true. We know that the measure of angle B is 52 degrees. And if I try to simplify this equation so that the thing I'm looking for is not in a denominator, I'm going to multiply both sides of this equation by side C, and then divide both sides of the equation by the cosine of 52 degrees, so that C, the thing I'm looking for, is by itself. Now let's simplify all this. The angle, the cosine of 52 degrees divides out, and on the left, I'm left with side C. On the right, I have an 11 in the numerator and the cosine of 52 degrees in the denominator. And that's how I'm going to find an approximation for side C. All right, so we have 11 divided by 52 cosine. I get 0.6166. Oh, that's the cosine. Okay, equals. All right, so we get that C is approximately 17 point, let's use one decimal place here. So approximately 17.9 units. That can be correct because I know that C, the hypotenuse, should have the longest length. And it is longer than side A that we already knew. How can we find the length of side B? Absolutely. We know that A squared plus B squared is C squared This is the Pythagorean identity. And that you really, really should know until you have, well, until you die, you should know that. We know that A is 11 units. We don't know B. We know that C is approximately 17.9 units. Let's see what we get. 17.9 squared is 320.41. 11 squared is 121. Let's subtract 121 from both sides. I think I'm back. And we get that 320.41 minus 121 is 199.41. I'm going to use all the decimal places after I rounded 17 point whatever it was to 17.9. When I square, you see that I get 2 decimal places here. I'm going to leave those 2 decimal places until I find b, the square root of b squared. So let's find the square root. Now I'm going to round. So I get that b is approximately 14.1. Let's look at our triangle. So B is approximately 14.1 units. C was approximately 17.9 units. Now the sides should be small or large relative to the size of the opposite angle. So 14.1 should be opposite the middle angle. 17.9 should be opposite the largest angle. That means angle A should be the smallest. Well, let's see. We know how to find angle A. We know that the measure of angle A plus 52 degrees is equal to 90 degrees. Because the sum of all 3 angles is 180 degrees, and we know that C is 90. So we just subtracted from 90. Now, if we subtract 52 from both sides, we get that the measure of angle A is 38 degrees. And yes, angle A is the smallest. So these all make sense. Solve now the right triangle where angle A is 20 degrees, side A is 5.2, and we don't know anything else. Wow, okay. So here's angle C. It's the one that is 90 degrees. I'm going to let angle A be on the left. Angle A was 20 degrees. Angle B is on the right. The side opposite angle A is small a, and that's 5.2. The side opposite angle B is small b, and the side opposite angle C is small c. Now, we actually know all 3 angles because we know the measure of angle B is equal to 90 degrees minus the measure of angle 20. And 90 minus 20 is 70 degrees. So we know the measure of angle B is 70 degrees. We can use either angle. We want to find a trig identity that involves angle A or angle B and the side A and the side C. That's the easiest way to go. Well, if I do it with respect to angle A, I know that the sine of A is opposite over hypotenuse, and that's 5.2 over angle C, over side C, pardon me. I'm going to multiply both sides of this by C. And now I have that C times the sine of 20 degrees equals 5.2. But are we looking for the C times sine of 20 degrees, or are we looking for C? Absolutely, we're looking for side C. So I'm going to divide both sides of the sine of 20 so that I have C alone, and it happens to be on the left. Let's do this together. We know that C is 5.2 divided by 20 sine equals, and I get that C is approximately 15.2 units long. That clunk you heard was my calculator falling. Now, all we need is the length of angle B, of side B. Well, how can we find the length of side B? Excellent. We know that A squared plus B squared is C squared. A squared is 5.2. And C is approximately 15.2. $15.2 squared minus 5.2 squared equals 204. So B squared is equal to 204, and we're going to take the square root of both sides, and I get that B is approximately 14. It's going to be 14.3 because I'm rounding to one decimal place. Now let's look at these answers and see if they make sense. Which side has the longest length? Yeah, side C has the longest length, and it is the largest angle. The angle that comes next is angle B, and it has the middle length. The angle that is smallest by far is angle A, and it has much shorter length. So it looks good. Okay, now we're getting into something a little bit more fun. Applications of right triangles. So to solve an application involving a right triangle, you first want to sketch the situation as well as you can, as carefully as you can. You want to label all the sides that you know and everything you're looking for, and then you want to find the missing sides. Finally, you want to come back to the question and make sure you answer the original question. This first one I've worked out for you, but we're still going to go through it. But this solution is worked out in your notes, so all you need to do right now is pay attention. A beachgoer flies a kite on a windy day. He holds the spool of thread at a height of 4 feet above the ground, because that is the height of the child. And he notes that the string makes an angle, because this is a very sharp kid. The string makes an angle of 42 degrees with the horizontal. So if we have the horizon or the horizontal being the ground, then the angle of elevation is 42 degrees. If 120 feet of string is out and the sag is negligible, which means that the string is taut or tight, Taut is the word that you would use if you want to say the string is not loose. And it means it is tight, not sagging. Then we want to find the height of the kite to the nearest foot. So not only do we want to find side A, but we want to add 4 feet to side A so that we get the height of the kite with respect to the ground. Do we need to find side B this time? We don't need to. Oh, yes, we do. My mistake. Then find the horizontal distance of the kite from the beachgoer. So side B is going to be that horizontal distance from the child to the kite. So how can we use the fact that we know the hypotenuse, we know the angle? What trig identity combines the side opposite and the hypotenuse? Excellent, excellent. We know that the sine of 42 degrees is side A over 120 feet. And if I multiply both sides by 120, I'm going to multiply by feet as well so that I have feet in my answer. I get that the sine of 42 degrees times 120 feet equals side A. Okay, 42 sine is 0.669136, etc., times 120, and we get that side A is approximately 80.3 feet. Now, does the value A answer the question? Does it? Exactly right, it doesn't. We want the height of the kite with respect to the ground. So we need to add 4 to get the height of the kite with respect to the ground. So I get 84.3 feet to answer part A. This is the height of the kite. Now we also needed the distance from the child to the kite, the horizontal distance. We're going to find this in 2 ways. The first way, we're going to remember that the cosine of angle 42 will be side B, the adjacent side, divided by the hypotenuse. So we know that the cosine of 42 degrees is side B divided by the hypotenuse. Again, we're going to multiply both sides by 120 feet. And we get that side B is the cosine of 42 degrees times 120 feet. And that's 89.2 feet. How can I check? Or how can I find B in another way? I know 2 sides of a right triangle. How can I find a third without using trig? Excellent. We know that A squared plus B squared should be equal to C squared. So let's find both of these quantities and make sure we get the same value. Side A was 80.3. Side B was 89.2. Side C is 120. 120 squared is 14,400. 80.3 squared is 64,048.09. 89.2 squared is 79,056.64. And what is the sum on the left-hand side? 644.8.09. Awesome. We get that the left-hand side adds up to 14,404.73. If we had written our answers more to the exact answers, oh, this one's to the nearest foot. Okay, so let's even do better here. I was getting to the nearest 1/10 of a foot. So now let's check our answers with this bigger rounding. So our answers will be farther apart, but that's okay. We're going to say that B is approximately 89 feet, and A is approximately, instead of 80.3, we're going to say 80 feet. And now let's find A squared plus B squared. 89 squared plus 80 squared is equal to 14,321. C isn't going to change. We had C, an exact value for angle C. So do you see how close we are, even though we've done quite a bit of rounding? So we know that our answers are good. Okay, great. Another question. A 40-foot ladder on a fire truck leans against a burning building so that the top of the ladder makes an angle of 20 degrees with the building. I'm going to have to draw this in order to visualize. So here's the building. Sorry, this is my mom. I'm back. So, oh, just a moment. Let me see what that is. Okay, I've tried to turn every single thing off that I can possibly turn off. I'm hoping that nothing else rings, buzzes, or whatever. So let's draw the picture here. We have a burning building. We have a 40-foot ladder on a fire truck that's leaning against the burning building. So we're going to draw a fancy fire truck. It has double wheels. It's a big fire truck. And it has a ladder, 40-foot ladder, that leans against the building with an angle 20 degrees with the building. So our triangle, our right triangle, has angles 20 degrees. What will the angle at the lower end be if the upper angle is 20? Absolutely. It'll be 90 minus 20, which is 70 degrees. We want to find, we know that the distance from the base of the ladder to the ground is 6 feet. And we want to find how far above the ground the ladder reaches to the nearest tenth of a foot. So ultimately, we want to find this height X, but what we can find first, I'm going to label this angle A and call this side A. And how can we find side A? Awesome. We know that the sine of angle A is opposite over hypotenuse. I'm going to multiply both sides by 40, and I get that 40 feet times the sine of 70 degrees will be side A. So we have the sine of 70 times 40. And I get that the length of, let's see if I can make this better. I'm not sure what that does, but let's find out. We get that the length or the height, pardon me, of side A is 37. I'm going to leave it complete. No, actually, I don't know what I'm saying. Since we want the answer to the nearest tenth of a foot, I'm going to round this to the nearest tenth, and I get 37.6 feet. Well, high is the ladder with respect to the ground. Yes, to find X, we need to add 6 feet. So that X equals 37.6 feet plus 6 feet. 7 and 6 are 13. So I get that X is approximately 43.6 feet. Another fun one. Find the pitch of a roof to the nearest tenth of a degree if the roof is 6 feet high at the highest, and in total, the roof is 15 feet wide. Okay, let's see. 15 feet wide. The height at the highest, which would be in the middle, is 6 feet. And we want the pitch. I'm pretty sure the pitch is this angle opposite 6. I'm going to let 6 feet be side A and call this angle A. We don't know the hypotenuse. We're going to call this C. And we don't know the base. We don't know the length of B. But we know the total length. And I've drawn this so that the height is in the middle. We have to assume that's what it is, because otherwise we couldn't find the answer. So B is going to be 15 divided by 2, which is 7.5 feet. How can we find side C? Or do we even need to find side C? Can we find the angle for angle A? Can we find its measure if we know the height and the base? Absolutely. Which trigonometric identity involves the lengths of the legs? Excellent. The tangent of A is opposite over adjacent. The opposite length is 6 feet. The adjacent length is 7.5 feet. Notice that the feet divide out. So the tangent of angle A has no units. And let's figure out what the tangent of angle A is. So we've got 6 divided by 7.5. We get that the tangent of angle A is 0.8. To find angle A, we're going to take the arctan of both sides. Let's write this prettier. Arctan of the tan of A will equal the arctan of 0.8. Well, the arctangent of the tangent of A is just A. So angle A is equal to the arctangent of 0.8. 0.8. To get arctangent or inverse tangent on my calculator, I have to hit the second button, and there's inverse tangent. And I'm in degrees because the radian button, see the radian button shows, and when it's not showing, I know I'm in degrees. I get 38.7 degrees. Eye level of 6 feet. An observer standing 30 feet away from a building sights the bottom of a window at elevation of 6.1 degrees. He sights the top of the window at an angle at an elevation of 20.1 degrees. Find the vertical dimension of the window, round to the nearest tenth of a foot. Okay, see, we have a 6-foot high figure. And let's see, 6 feet. From their point of view, so when they're 30 feet away from whatever it is, let's make this, we've got 30 feet. And from his point of view, he sees the bottom of a window. There's the window. The bottom of the window is at an angle of 20.1 degrees. The top of the window is at an elevation of 20.1 degrees. Oh, wait, I see. So 6.1 degrees for the bottom, 20.1 degrees for the top, and we want to find X, the height of the window. Is that right? Yes, to the nearest tenth of a foot. So what in the world? Well, let's see. A right angle has the base at the angle of line of sight for the person. So we've got 2 right triangles. We have one, remember the base is 30 feet. One right triangle has the lower angle of 6.1 degrees. And let's call this A1 for angle 1. The other triangle is also, the base is also 30 feet. We're going to call this A2 for angle 2, and this one is 20.1 degrees. A2 is this base all the way up to the top of the window. A1 is from the base to the bottom of the window, how can we find X if we can find A2 and A1? Excellent. We know that A2 minus A1 will give us X, and that will be the height of the window. So in our two triangles, we want to find the length of the opposite side. We know the adjacent side, and we know that A2 minus A1 will give us the height of the window. What trig identity involves the side opposite and the side adjacent? Excellent. We know that the tangent of A1 and the tangent of A2 is opposite over adjacent. The opposite for the angle triangle 1 is A1 over 30 feet. And for the second triangle, it's A2 over 30 feet. I can multiply both equations by 30 on both sides, and I get that 30 feet times the tangent of 6.1 degrees will be side A, and I get that 30 feet times the tangent of 20.1 degrees will be the length A2. How did I lose my triangle? How did I lose my phone? Okay, let me find my phone. I'll be right back. I couldn't find my phone because it was right in front of my face. All right, let's do this. We're in degree mode because there's no radian there. So I've got 30. I'm going to do the angle of the tangent first. 6.1 tangent times 30. I get the A1. And we want to the nearest tenth of a foot. A1 is approximately 3.2 feet. A2 will be the tangent of 20.1 feet. 20.1 degrees times 30 feet, which will be 10.978, but we're rounding to one decimal place, so we round up to 11.0. And the height that we're trying to find is the difference of A1 and A2. So 11 minus 3.2, 7.8. So the window is about 7.8 feet tall. Did we answer the correct question? Yes. An airplane begins its descent at an average speed of 200 miles per hour. Okay, speed is 200 miles per hour. I'm writing it out because, excuse me, this is a very unbeautiful, there we go. An angle of depression so an angle with respect to some horizontal. So here's the plane. I'm an artist, yes, yes. Okay, so the angle of depression is 15 degrees. Find the number of vertical and horizontal miles the plane will cover in 2 minutes. So he's traveling 200 miles per hour, and we're looking at 2 minutes. So T equals 2 minutes. And in that time, we want to see how far he's gone vertically and horizontally. I'm going to call the vertical A, the horizontal B. And we should know C. Now, we don't talk about geometry a lot in this class, but if we have two parallel lines, I'm going to say that the line we're using to figure this 15-degree depression is parallel to the Earth. And now I have an angle, a line cutting. That means that the inside angles are the same and the outside angles are the same. Well, we're concerned here with the inside angles. So I have one angle of a triangle, and I just need to see how long is side C. I'm going 200 miles per hour for 2 minutes. Wait, minutes and hours, those are not the same. How can I convert minutes into hours? Let's multiply by unity. I'm going to put minutes in the denominator, therefore, and hours in the numerator. Hours and minutes. Oh, I know that 60 minutes is 1 hour. So if I multiply by 1 over 60, I'll convert 2 minutes into hours. I can even reduce the 2 and the 60. So I can divide 1 by 30 and get how many hours this plane will travel at 200 miles per hour for 2 minutes. So C is going to be, this side C is going to be 1 divided by 30 hours. This is not side C, this is how long it's traveling. So the time it's traveling is the reciprocal of 30, or 1 divided by 30. And it's 0.033, and I'm just going to put a bar because it's repeating. If I multiply the speed, remember, I'm going to write speed as miles divided by hours. If I multiply the speed by the time is in hours. I have 0.033 hours. Do you see that the units for hours divides out, and I'm going to have a distance just in miles left? So I'm going to actually divide both sides by 30 instead of multiplying by the reciprocal. So I've got 200 divided by 30, and it's 6.6, repeating. Miles. You know, I can make this prettier. Let's make it prettier. So we've got T is equal to 1 over 30 hours. And the distance is equal to 200 miles per hour times 1 over 30 hours. And let's reduce. We can divide both of them by 10. And I get that the distance is exactly 20 divided by 3. And that distance is side C. C is equal to 20 over 3 miles. Now, how can I find A and B knowing side C, knowing the hypotenuse? This is really, really important. We're going to be doing this a lot going forward. So we know that the sine of 15 degrees, well, sine is opposite over hypotenuse. And to get the opposite side, I'm going to multiply both sides by the hypotenuse. And I get that side A, the vertical side, is the length of the hypotenuse times the sine of the angle. So that is. So we have 15 sine times 20 divided by 3. And I get that the vertical height, so the vertical distance, is 1.7. It didn't say how accurate, so I'm going to do one decimal place. 1.7 miles. Side B is adjacent to angle 15. So B is equal to, I know that the sine, the cosine of 15 degrees is adjacent over hypotenuse, adjacent over hypotenuse. I can multiply both sides by C, and I get C times the cosine of 15 degrees is the vertical, pardon me, the horizontal distance. Well, C is just 20 over 3 miles, and we're multiplying that by the cosine of 15 degrees. Let's see what that is approximately. 15 cosine times 20 divided by 3. I get 6.4 miles. Is there a way I can check my answer? If I've got, I'm going to try to zoom out here a little bit. All right, so we've got B is approximately 6.4 miles. A is approximately 1.7 miles. And we know that side C is 20 over 3 miles. How can we check our work? Excellent. We know that A squared plus B squared should be C squared. A is approximately 1.7 miles. B is approximately 6.4 miles. And C is exactly 20 over 3 miles. Okay, 1.7 squared is 2.89. 6.4 squared is 40.96. And if we add those, 2.89, we get 43.85. What do we get when we multiply 20 over 3 by itself? Well, 20 squared divided by 3 squared is 9, so divided by 9 is 44.444, so 44.4. Repeating, that's pretty close. And the reason why there is a difference is that we're rounding to 1 decimal place. Great. Oh, I do want you to attend to the fact that the horizontal component or part of this distance was found by multiplying by the cosine, and the vertical component or the vertical part of this distance was found by taking the sine. Bearings. That's the last thing we're doing today, so that's great. The bearing from point A to point B is the degree measure of the acute angle. And this is important. That acute means between 0 degrees and 90 degrees. So the acute angle formed by the ray AB and the north-south line. Let's say here's AB, here's the north-south line. Which angle in here? There are 1, 2, 3, 4 angles. Which one is less than 90 degrees? Yes, this one. And it's the same angle because we've got two lines. That means that their angles are the same. The angle between the two lines is the same. So either angle will be correct. But which one? The bearing is denoted by the letters north or south, followed by the measure of the acute angle in degrees, followed by the letters east or west. Oh, okay. So if we're going from A to B, we would measure, say this is 30 degrees. We would say AB is north 30 degrees. Here's west. Here's east. B is on the east side. So I would say north, because B is on the north 30 degrees east. If the arrow was going the opposite way, so what if we started at B and we went toward A? We still have this inside angle is 30 degrees. Now A is, this is B, south 30 degrees west. So let's look at a couple of examples and then let's do an actual problem. And I think that's it for today. Yes, that's it. Notice the bearings given for the following rays from point A to point B. Find the bearings from B to A. So from A to B, do you notice that every single one of these rays starts with angle, pardon me, starts with point A being at the origin? Do you see that A is at the origin every time? That means that this ray AB is in standard form. Starts at the origin. We're given information for from A to B, and we want to give information for from B to A. AB is north because it's above the east-west line, 42 degrees, and it's to the right of the north-south line, so it's east. What would BA be? BA would be pointing down. Imagine point B being at the origin so that A is now lower. BA would be going south. The angle will be the same. And now it's west. So to go from A to B and then change that to B to A, south becomes north, east becomes west, the angle stays the same. So let's write down AB is 74 degrees and acute angle. Let's see. Acute angles are between 0 degrees and 90 degrees. So yes, 74 degrees is an acute angle. So we would say A to B is north, 74 degrees. The line, the AB line is to the left of the north-south line, so it would be west. That means that BA would be south. It's always the opposite, and it's going to be east, but the angle will be the same. And the way that we think of that is we're going to transfer point B to the origin by sliding. So it's going to look like this. Point B becomes the origin, and now point A is going down. The angle is still the same. But now BA is below the east-west line, so it's south, and to the right of the north-south line, so it's east. Well, I can see that AB is below the east-west line, so it's going to be south, and to the left of the north-south line, so it's going to be west, and the angle is 40 degrees. That means that BA will be north instead of south, east instead of west, but still 40 degrees. Finally, let's look at this ray AB. They tell us that its acute angle is 69 degrees. And I can see that AB is below the east-west line, so south, to the right of the north-south line, so east, and it's 69 degrees. That means that BA will be north, 69 degrees west. Let's do one more example with just figuring out bearings, and then let's use bearings. We want to find the bearings from point 0, which is the origin, I see. So from the origin to point C. From the origin to point C. The angle is 40 degrees. The angle from the north-south line to the ray is 40 degrees. The ray is below the east-west line. So it'll be south, 40 degrees, and the ray is to the right of the north-south line, so east. What about OB? From the origin to B, the ray OB is above the east-west line, so it's going to be north. It's fun. So they tell us that from the positive x-axis all the way to the ray OB is 118 degrees. The angle we want, let's call it, what do we want to call it? Let's call it little b. And how can we find little b if we know this whole, from the positive x-axis all the way over to ray OB? Well, what is the rest? What is the measure, angle, degree measure of one quadrant? Excellent. So I know that B plus 90 degrees is 118 degrees. So I can subtract 90 degrees from both sides, and I get that angle B is 28 degrees. It's north, 28 degrees, and notice that OB is to the left of the north-south line, so it will be west. Now to go from A to the origin, we're going to go in reverse. Okay, so let's draw that in standard form. I'm going to draw A as though it's at the origin. And I'm going to continue to call the second point O and pretend like it's not the origin. The angle that they gave us was 22 degrees. So we know that the ray AO is 22 degrees from the negative x-axis. But that's not the angle away from the north-south line. I need the angle that OA makes with respect to the north-south line. How can I find that? In other words, what is the entire angle from the negative x-axis to the negative y-axis? Excellent. We know that the whole angle is 90 degrees. And if we subtract 22, we'll get the part that we want. 10 minus 2 is 8. 8 minus 2 is 6. So our angle is 68 degrees with respect to the north-south line. Now, AO is below the east-west line, so it is south. 68 degrees. It is to the left of the north-south line, so it is west. Right. Plane leaves an airport heading south 32 degrees west at 320 knots. That is nautical miles per hour. Determine the number of nautical miles south and the number of nautical miles west that the plane travels in 1.2 hours. So our time is 1.2 hours. The speed, I'm going to put velocity. So 320 nautical miles per hour. I'm going to put nautical miles per hour. And we want to find this distance P and this distance A. We know, here's the north-south line. Here's the west-east line. We know our plane is flying south 32 degrees west. So we're below the east-west line. We're 32 degrees away. And we are west. That means that we are to the left of the north-south line. Okay, so here's our plane flying 320 20 knots. We want to find the height and the vertical and the horizontal displacement or difference. And let's call the vertical displacement B and the horizontal displacement A. First, we want to convert the speed or the velocity together with the time to a distance. And I know that distance equals rate times time. Distance equals rate times time. Well, rate and velocity are the same thing. So I can multiply the speed by the time. Notice that the units are the same this time. The time is in hours and the velocity is miles per hour. So I just multiply 320 times 1.2 to get miles. And let's see what that is. $320 times 1.2, and we get 384 miles. I'm going to call this C. It'll be 384 miles. To find the component, the horizontal component, let's think of what we know about angles. So we've got 32 degrees. The opposite side is A. The hypotenuse is 384. So we could say that the sine of 32 degrees will be A over 384 miles. We can multiply both sides by 384. And we get that the horizontal distance will be 384 miles times the sine of 32 degrees. Let's see what that is. 32 sine times 384. And we get that the horizontal displacement or distance is approximately, it says to the nearest nautical mile. So we're going to round to the nearest mile, is approximately 203 miles. The vertical displacement, well, here's our angle 32. B is adjacent to 32 degrees. So to find B, we're going to say the cosine of 32 degrees is B over C. C is 384 miles. So let's multiply both sides of this by 384 miles. And we get that 384 miles times the cosine of 32 degrees will be the vertical distance. Let's see what that is. And we get approximately, and remember, we're rounding to the nearest nautical mile. So we get approximately 326 miles. And that's check. Here we've got our triangle. We have that side C is 384, and they're nautical miles, but I'm not going to put that. A was approximately 203, and B was approximately, oh, I have them backward, sorry. A was approximately 203 miles, B was approximately 326 miles. How can we check our work? Absolutely. We know the Pythagorean theorem. We know that 203 squared plus 326 squared should be equal to 384 squared. Let's see what we get. 203 squared plus 326 squared equals, get on the left 147,485. And on the right, we have 384 squared. We get 147,000, yay, 458. Very close, very close. Why are we not getting exact agreement here? Excellent, that's exactly right. Because of all the rounding. So rounding means there will be error in the answers. It also means, though, that the answers are more easily used and more easily understood. All right, that's it for this lecture. Hope you're doing well, and I will see you soon.